Right, so welcome to another video. Again, for some context, this video is specifically designed for my students, the students that I tutor, because my wife and I, we have a tuition service. We call it Sure Success Tuition, where we tutor students either in person or online. We tutor NGSA and C6 students in maths, English A, Social Studies, and English B. So the number is on the screen, 592-680-5143. If you are interested, you could feel free to call. Also, if this video has helped in any way, you can feel free to like, subscribe, and share. So in this video, what we would learn? We would learn the basics, the extreme basics of a fraction. So how would you answer this question here? What is a fraction? We will hear all sorts of definitions, but do we understand it? The most common definition is a fraction is a part of a whole, or we might hear it is not the whole thing. It is really a piece of something. Okay, that is true. But what is a whole? That is the next question. And since a fraction is a part of a whole, what really is a whole? How would we answer that? Well, this is quite simple. A whole is something that is complete. A whole is something that has nothing missing. So that is what a whole is. So very basically, we could understand a fraction, but for some reason, I don't know why it is so difficult to get this concept. But let's remember this basic here. A fraction is a part of a whole, and the whole is something that is complete with nothing missing. But as it relates to fractions, let's note a few things. So this whole, what we call the whole can be anything. And I mean it, the whole can be anything. For example, the whole can be one singular, one object. The whole can be a collection of objects. Now, this might seem a bit puzzling, but we'll see why this shouldn't confuse us. We also see that the whole could be the capacity of something. The whole can be the distance between 2 points. The whole can be a certain amount of money. And we name fractions, but in order to name a fraction, we must know how many equal parts it was divided into. So the whole must be divided into equal parts before we could name the fraction, because that is important. But this third point is also important. Fractions are numbers, right? Don't forget that. Although we would write a fraction using two numbers, they are actually one number, right? Because if we were to perform the division, a fraction is really a form of division. If we perform that division problem, we will get one answer. Think of it also. Fractions can be plotted on a number line. So what goes on number lines? Numbers. So a fraction is a number. So remember that. Don't get confused with that later on. So let's dive a little deeper into this whole and understand it. So we see that the whole could be one object. Look at this cake. This whole could be the cake. The whole, sorry, could be this one cake. This one cake can be the whole. Why? Because no part is missing. We have the whole cake. No greedy person went and ate the cake. No rat nibbled the cake. So we have the whole cake. Nothing is missing. The whole cake. Look at this here. Now, a collection of objects. Now, here we have a few drinks, right? But this entire case here could be the whole. Now, in this case, the whole is made, it was funny saying this case and it's a case. Now, in this case, the whole is this entire case of 24 drinks. Notice no drink is missing. All 24 drinks are there. So we have the entire case. We have the whole case. In certain contexts, the whole could have been one drink, but in this context, the whole is the entire case. Here we see that the whole could be the capacity of something. It could be the capacity of your battery, either on your laptop, your cell phone, tablet, whatever. So we could imagine that this battery's capacity is the whole. So if we were to charge this battery to full power and we do not use a single bit of it, we can say we have the whole battery. The battery is full. We have the whole battery. And similarly with this here. Some of you might be too young to recognize this, but you should. Right? So again, the capacity of something. So imagine this vehicle's fuel tank is the whole. So if we were to fill it up and we do not use any of it, we would have the whole tank. Right? Again, understanding the whole, a collection of objects. In this case, it's a collection of people, students. Let's imagine these to be a class, probably your class. We have 1, 2, 3, 4, 1, 2, 3. So 4 by 3, 12. We have 12 students. So imagine if no student is missing. We could say we have the whole class. So again, the whole class is made up of many students. So together, they would be the whole. Look, I like this picture. Look at this. So the whole could be an amount of money. And so imagine this. Imagine if, let's call this boy John. I don't know his name, but let's say he's John. And let's say his father gives him $600. And this $600 is his daily allowance. We could imagine that this daily allowance is the whole allowance. So if he does not spend any of it, he would have his whole allowance. Again, the whole could be the distance between 2 points. So we have this school and we have this home. So imagine if Sam, he walks 2 kilometers. The distance from his school and home is 2 kilometers. That entire 2 kilometers would be the whole distance. So if he was to walk from school to home, he would have walked the entire distance, or he would have walked the whole distance. Again, the whole being the distance between 2 points. So how now do we represent fractions in writing? You have ways to represent it with pictures and what have you. But in writing, it's simple. In writing, a fraction has 2 parts, basically. We have a numerator. And the numerator is the number that is above the line. We'll see that in a diagram just now. And the numerator has a function. The numerator has a purpose. The numerator tells us how many equal parts of the fraction we have. And then we have the denominator, that is the number below the line. So what do you think the denominator does? What is the function of a denominator? Well, it's easy. The denominator tells us how many equal parts the whole has been divided into. So if you have a whole, whatsoever the whole is, and you divided that whole into 10 equal parts, the denominator would be 10 to show that the whole was divided into 10. Now, if you were to collect all 10 parts, you would have had the whole. So we could say also that the denominator tells us how many parts we need to collect to make a whole. So let's have how it looks here. We have 1 over 2. That's how I read it. It's easier for me, but it's a half. You would know it as a half. The 1, that's the numerator. The 2, that's the denominator. And this little line here that separates the numerator from the denominator, we can call it a fraction bar, or if you want to sound fancy, you can call it a vinculum. whatever tickles your fancy. So let's understand how fractions work. Remember this, a fraction is always relative to a whole. So anytime we are talking about fractions, it has some whole somewhere looking about. We deal with fractions and wholes. A fraction is relative to a whole. So let's look at this fraction here. 1/5 or 1/5. What does this mean? Well, since the denominator is 5, this tells us that the whole was divided into 5 equal parts. Again, the whole can be anything. And whatever the whole was, it was divided into 5 equal parts. Or we can say 5 parts would make the whole. Since the numerator is 1, this tells us that we have one of those parts. So let's get some more concrete examples. So you have the whole being one object. So look at it here. Let's say this square was the whole. We're trying to understand a half. So remember that. So this square is the whole. Now, since the denominator is 2, what must we do with this square? Because this square is our whole in this case. The denominator is 2. What must we do with this square? Well, we must divide it into 2 equal parts. We could choose to divide it any way we want, but let's do it this way. So are we seeing it's divided into 2 equal parts? Are we seeing that? Look at the equal parts here. 1 equal part, 2 equal parts. So 2 equal parts. Okay, so the denominator tells us how many equal parts to divide it into. But we have a numerator. This numerator is 1. So what must we do? What is the function of the numerator? Well, it tells us we need to take one of these equal parts. So let's just take one. We take this part here. So we see the function of the numerator and the denominator together, they communicate something to us. Again, we're seeing that the whole could be the distance between 2 points. So we have point A and point B. This is the distance between them. So we're seeing that distance there. So the denominator is 2. What is this telling us to do? With the whole distance, divide the whole distance into 2 parts. So are we seeing it being divided there into 2 parts, 2 equal parts, the distance. Now the numerator is 1. What is this telling us to do? Let's take one of those parts. We're taking this part. That's ours. So again, if the whole was the distance between these 2 points, a half of that whole would be what we did here. So again, the whole could be anything. Let's say the whole is a collection of objects. Let's get back our class of 12 students. Our denominator is 2. What do? What must we do with this whole? The denominator is 2. Well, we must divide it into 2 equal parts. So let's see. It's divided into 2 equal parts. Good. The numerator is telling us something. What must we do because of the numerator? Well, let's take one of those parts. See? We take one of those parts. That is what the numerator tells us. So both the numerator and the denominator has a function. Again, let's imagine the whole being a certain amount of money. In this case, let's say it's $1,000. So since the denominator is 2, what must we do with this whole amount of money? We must divide it into 2 equal parts. So that will give us $2,500, right? We're seeing it divided into 2 equal parts. Great. What is the 1 telling us to do? Well, we must take one of these parts. So let's take this one for ourselves. Again, that is what it is telling us to do with the whole. A fraction is always relative to a whole. So let's try one for yourself. 3/4, 3/4. What does this really mean? If the whole was one object, what must we do? What must we do? Well, the denominator is 4. So let's divide it into 4 equal parts. That is what the denominator is telling us to do. Good. The numerator is 3. So what is this telling us to do? Very good. Take 3 of these parts. Very good. 3/4. 3/4. Let's say it's the distance between 2 points now, A and B. Right? This is the distance between A and B. That's the whole distance we are interested in. The denominator is 4. What is this telling us to do? Very good. Very good. I know you are catching on. So divide this distance into 4 equal parts. Let's do that. Now, don't get confused with the amount of lines you are seeing here. This is still 4 equal parts. Look at this here. This is 1. This is another one. Another one. Another one. So how many parts you have? 1, 2, 3, 4. 4 equal parts. The numerator is 3, so what must we do with these equal parts? Here, we need to take 3 of these equal parts. Now, we could have taken any 3. I just chose to take 3 in a row like this. 3/4 of this distance, 3/4 of this whole. That is what this means. A collection of things now. Let's imagine our class again. What is the 4, the denominator, telling us what we must do with this whole? In this case, the class is the whole. We must divide it into 4. Not so? Let's do that. 4. Wow, easy. 4. What the numerator telling us to do? Very simple. Take 3 of those. Let's take 3. Any 3 would have worked. We take 3. Let's take 3. So that is what 3/4 of this whole class of 12 students would be. 9 students would be 3/4 of this class. Any 9. You could have taken any 9. So let's do everybody's favorite thing, money. So the whole is an amount of money in this case. The denominator being 4 is telling us to do what? What is the denominator telling us to do with this whole? Divide it into 4 equal parts. So if we were to divide 1,000 into 4 equal parts, how much would we get for each part? 250. Are we seeing that? Very good. So what is the 3 telling us to do? That's the numerator. Take 3 of those parts. Very good. So a fraction is very simple. Please try to understand this concept. Thank you for watching. Please remember to like and subscribe. Thank you.